Start the recording. All right, guys, welcome back. We are back with our NSE4 Journey, right? But of course, this week we're getting a little bit of help, right, from Cisco, right, because has requested we are covering, right, key topics in routing and switching, right, to help our engineers be effective as network security engineers, right? A refresher is always good, okay? Right? So, of course, like I always tell you guys, please look at the OSI model, burn it into your head so that you know how to ramble off the OSI model to a T. Okay? So, let's go ahead, right? Skip all of this, right? We spoke about switches, right? We spoke about switching, right? Tonight is going to be about routing, right? And so, how do we connect, right, the world to each other, right? We connected by the wide area network, right? The WAN, right? We're connecting private area networks, right? To by using public area networks. Okay. So we connecting our LANs together, by WAN. Okay. All right. Simple enough, right? Another term for the physical medium that is used for WANs are called lease lines. Okay. Right? And their type of technology, right, differs from what's used within the LAN, right? The LAN may use copper cable, right? Right? Technology has improved over the years, right? And lease lines, right? WAN technology, right, now uses fiber. Okay, you can now have a fiber connection that spans and have greater distances versus Ethernet cable, right? That's used for LAN, right? It can go underground. It can so many things. It can go above the, maybe within the, above the roof or what have you. It's so many things fiber can do, right? The core thing I want you guys to understand that it can span for miles, right? It is a WAN technology, right? At layer one, right? And it connects, right? LANs, right, by using a wide area network technology. Okay, right? Some of the things that you guys are going to hear being network security engineers, right, is different names for for the WAN, right? You may hear it, somebody call it a circuit, leaf circuit, serial link, serial line, point-to-point link, point-to-point line, T1 link, WAN link, link, private line, right? So many words, right? But all of these words mean the same thing, right? Which is it is a lease line. It is a line that your business or yourself is paying for, right? For the service of connecting your local area network to the world, right? Giving it access, all right? Okay, I'm not going to read off this chart, right? I know you guys are very intelligent, so take a look at it, right? There's slight differences within, of course, each name, right? Like T1 or what have you. But take a look at it when you have the time. This is in your book, right? Your CCNA 200-301, right? Volume 1. Go ahead and read it when you have a chance. And yeah, feel free to come back to me for any questions, and I will answer them the best that I can, right? If I can't answer it, I'll go ahead and share a resource. Okay. Now, you guys are probably wondering, right? How does the world operate as it does? Right? Right? We have companies, right? Telcos, right? That offers us those lease lines, right? To connect, of course, right? The world, right? And let's say, right, Markivia is customer, she's a customer in a sense, right? She has two sites. She has site one and site two, right? But she wants to make sure both of these sites can communicate to each other, right? She can pay for a lease line, right, from her company, right, her telco company, her ISP, right, to go ahead and have that lease line between these two buildings. Okay, this is typically how a lease line looks. Okay. Now, I've spoken to you guys about, of course, layer 3 is strictly layer 3. And routers are only focused on looking at the packet, right, from a layer 3 perspective, right? Well, whether we like it or not, it still has to put packets, right, because we're at layer 3 now, on the wire, right? So we need to go ahead and encapsulate it, right, into layer 2, right, to prepare it for layer 1, right? But again, it's a router, right? So do we have Ethernet technology, right? Did routers start out with Ethernet technology embedded into it? No, it did not, right? Because Ethernet, right, 802.3, right, was built into switches, not routers, right? So what Cisco did, right, what the world did, right, they said, hey, the routers need to put things on the wire, right, but we need to make a way so that it can communicate at layer 2, right, and prepare these packets to go ahead and be transmitted, right? They have a technology called HDLC, okay? And so this is a layer 2 technology of a router, right? So if the router is going to encapsulate that packet, right, with the payload, it's going to go ahead and put an HDLC header and trailer, right, from a router standpoint. Okay, all right. You guys learned about headers and trailers as it relates to Ethernet, right, and layer 2 yesterday, right? So this is no different. This is just another name for it at layer 3. Okay, so here's an example, right? Here's the routing logic over LANs and WANs, right? So PC1, right? It's trying to get to PC2, right? And so PC1 says, hey, I'm trying to get to PC2. I'm going to go ahead and send it to R1, right? And send it to R1, right? It's the default gateway, right? R1 gets it, say, hey, how do I get there? Oh, to get there, I need to send this traffic to R2, right? It's going to go ahead over the WAN, right? Wide area network, send that traffic to R2. R2 will get it. It'll say, hey, all right, I know how to get to PC2. And then go ahead and forward it, right? This is a high level breakdown of how IP routing works, right? From LANs to WANs, right? From private networks to public networks, right? To private networks again. Okay, right? Here's an in-depth view of how that works, right? So we have PC1, right? PC1 has the packet, starts at layer 7, encapsulates it, right? Puts it on the wire, right? It has that header and trailer, right? 802.3, like I told you guys, right? Has the header and trailer around that packet, right? Switch gets it, switch forwards it to R1, right? R1 de-encapsulates it, right? Meaning it opens it up, right? And it checks the layer 3 section because that is the only thing the layer 3 routers are worried about, right? So it's going to look at that, but it still needs to send the packet to the destination, right? So after looking at its source and destination IP address, it's going to say, I know where to send it. I have a route for it programmed in my router, in my routing table, right? But I need to go ahead and encapsulate it at layer 2 so it can get sit on the wire. That router is going to say, hey, I may not, be Ethernet and use 802.3, but I have my own technology at layer 2. So I'm going to go ahead and put a header and trailer around my IP packet, right? HDLC, right? And send it to another router, right? Because this is how routers communicate with each other. R2 is going to get it. It's going to de-encapsulate it. R2 is going to realize, this is going on a local area network. I need to re-encapsulate it, right, with local area network technologies at layer 2, which is 802.3. Okay? Any questions?
None so far.
Okay. All right. So, of course, this book, right, the CCNA, right, it refers, right, to Ethernet WAN, right? Because that is a technology, right? Now that we've upgraded, right? We talked about history, we talked about HDLC. There is now a way to where you can use WAN technology, right, to extend layer 2, right? There's a couple names for it. You got Ethernet WAN, you have Ethernet line service, E-line, right? You have Ethernet emulation, right? You have Ethernet over MPLS, okay? All these different things, right? For your exam, you don't need to know these things in depth. This is just knowledge that you guys actually heard the words. And if you hear it, of course, on the job, in public, you guys actually know what it means, okay? So now that we're in modern times, we don't have to use HDLC anymore, right? Now our routers know how to speak the language, right, of local area networks, right? So now it'll go ahead, it won't put an HDLC header and trailer, it'll put an 802.3 header and trailer. Okay. And just like we talked about, right, in the path of the packet exercise, we have our source, right, R1's gigabit 0/1 MAC address, and our destination, R2's gigabit 0/0 MAC address, right? Because they still need to communicate via layer 2, right? Because it needs to get onto the wire. All right, let's keep going. All right, now let's talk about how IP routing works, right? So we have PC1 here, right? Let's talk about what PC1 is doing, right? It's trying to send a packet, right? The destination is in another group, another subnet, however you want to call it, right? PC1 doesn't know where exactly PC2 is. It's going to go ahead and send it to its nearby router, right? PC1 sends it, right? Sends it to its nearby router, which is R1. R1 says, and the packet says when R1 reads it, hey, I'm trying to get to PC2, right? R1 may not have a route specifically for PC2, but it knows about PC2's subnet. It's going to say, hey, I'm going to go ahead and send it to R2. R2 is going to do the same thing, do the same checkup. Then it's going to say, I don't know specifically where it's at. I know where the subnet is. It's going to send it to R3. R3 is going to say, this is for me, right? And it's going to go ahead and send, right? It's going to go ahead and send that packet down to PC2, right? So again, right? It's always going to forward an IP packet, right, to nearby routers in hopes to find the destination. Okay? All right? So here's in detail how it looks like, right? Right? And so PC1, right? Ethernet header and trailer, packet, sends it onto the wire, sends it to R1, right? R1 looks at its routing table. It says, oh, okay. I don't know how to go ahead and get to X, Y, and Z, right? Where am I going to send it to, right? If I don't know where the destination is, I'm going to go ahead and send it to R2, right? R2 is going to do the same thing. I see where the destination is for this packet, but I'm going to go ahead and try to get to, right, this subnet. And of course, and for this example, I'm sorry, I'm looking at it now. It does know how to get to it, and it has the next hop, right? So they know how to get to it, and it has the interface where it needs to egress out to get there, and it has actually the next hop, right? So each router is looking up, right, by looking at the IP packet, right, the layer 3 section, and saying, hey, the destination is for 150.150.4.0. I know where to send this, right? It's going to keep going and going and going until it gets to R3, and it's going to actually go ahead and drop it, right? The important part of this, right, is you can see, right, the network layer, the data link layer encapsulation of that packet to the frame, okay? From a layer 3 standpoint to a layer 2 standpoint, back to a layer 3 standpoint and beyond, okay? Let's take a step, right, step back, and let's talk about, right, IPv4, right? And we're talking about TCP/IP networking stack on your computer or on a host, how that routing process works, right? So if we have a PC, right? We have a PC, right? A PC can, if it's a PC, it has two options. If it needs to send, maybe a message locally, it's going to send it directly to that other host. If it needs to go ahead and send something, right, outside of the network, it's going to send that to its nearest gateway, right? Right? But what is happening, right, behind the scenes, right? So that PC is going to say, hey, if this destination is local, send directly, right? But how are we going to do that? That host is going to find a destination host MAC address, right? And Markavia, shout out to you for bringing up ARP. It is going to use its ARP table to see if it has an entry for that host. If it does not, right, it's going to go ahead and use ARP messages to learn that information. Once it does, right, step B is going to go ahead and now encapsulate the IP packet into a data link frame, right, with the destination data link address of that destination host and send it off. If the destination is not local, right, that host is going to send it to its default gateway, right? But it's going to do the same thing except for with the, with the default gateway. It's going to try to find the default gateway's MAC address, right? If the ARP table doesn't have it, it's going to use ARP messages to go ahead and get it, okay? Right? Once it has that information, it's going to encapsulate the packet, send it to the default gateway. Simple enough. But this is how on every host, every device that has a IP address, right, it is going to use this routing preference, right, to send frames, right, outside of its interface. Okay? All right. So, what are we looking at here, right? This is the process, right, a router takes to route traffic, right? This is what the routing logic looks like, right? We're going to break it down, right? Step one, right? Decide whether to process the incoming frame, right? And so what it's going to do first, right? Gigabit 0/1 for router 1 is going to go ahead and receive that frame, right? It's going to de-encapsulate it, right? But it's going to investigate first. Hey, right? I'm going to look at the header. Hey, is this my MAC address for gigabit 0/0? Is this meant for me, right? Right? Let's say yes, it is, right? But also we need to go ahead and check that trailer, right? Within the trailer, right, is it's going to go ahead and see if the FCS frame check sequence has been changed. If it has not, right, as long as this frame is destined for my interface, I'm going to go ahead and process that, right? So again, I need what the route is going to do first is one, check FCS, and two, check the destination MAC address to make sure this is the host that it was supposed to be sent to. Okay? So router 1 found out and decided, hey, this is for me, right? From a layer 2 perspective, right? So now router 1 is going to say, hey, I need to go ahead and de-encapsulate the packet, right? Because I'm still a router, right? I operate at layer 3, not at layer 2, right? So it's going to go ahead and de-encapsulate it and stop at layer 3, right? Look at the IP packet, look for the source and destination IP, and say, hey, okay, it needs to go to 172.16.2.9. This is just an example, right? But I know where the destination is at, right? What now, right, in step 3, right, it's going to choose where to forward the packet, right? Right? And so that router is going to say, do I have a matching route in my routing table, right? For where it needs to go to, right? For this example, 172.16.2.9, we have an entry, right? For the 172.16.0.2.0/24 network, right? To get there, we need to go out serial interface 0/0/0, and the next hop is going to be 172.16.4.2, right? I want you guys to look inside of the routing table, right? Because it's doing two functions that your firewalls do, your FortiGates do, right? First, it's going to match a condition, then it's going to perform an action after matching that condition, right? So the router is going to look at the IP packet, compare it with what it has in its routing table. As long as the criteria fits, it knows where to send it, okay? So again, step 3 is choosing where to forward the packet, okay? Now that we've chose on where to forward the packet, right? Now we need to go ahead and put the packet right back onto the wire, right? So step 4 is going to be encapsulating the packet in a new frame, okay? So now the router is going to say, all right, I need to go ahead and put on the wire. I'm going to use my layer 2 technology, right? Of course, for this example, it's using HDLC, right? Old school technology. And it's going to send it out of its serial interface, okay? All right. And so once it's prepared, right, and it's finally ready to go, then finally at step 5, it is going to transmit, right, that frame, right? Because now it's a frame now, it lists that layer 2, right? And sends it out via layer on layer 1, right? So send it out, it's gonna get to its destination. Okay. All right. That's routing. That's it. That is absolutely it, right? We're going to talk about some side, right? Some side topics, right? Side technology that you need to know in reference to routing, right? We have DNS, right? Domain name service, right? What does that do, right? Right. So what DNS does, right? It resolves, right, fully qualified domain names, right, our website address, or just by names to IP addresses, right? If you look at the DNS server in the in the screenshot, right, in the PowerPoint, you'll see, right, the DNS server name database will have a name, and associated with would have an IP address, right? So if we're looking at PC11, right, still using the TCP/IP stack, what is it doing, right? PC11 is going to send a request to server 1, right? PC11 has the DNS server configured, and it's going to say, hey, what's the IP address of server 1? DNS server is going to respond back to that host of PC11 and say, server 1 is 10.1.2.3, right? So it's going to do some, aka a route lookup, right? It's going to do a lookup and use routing and switching and say, hey, I know where to send this, right? By IP address, right? And then PC11 is going to start performing IP functions, right? IP routing functions, right? And performing that logic, all right? So DNS is an important thing as a network security engineer. You need to understand how it works. Hopefully I gave you guys the most simplest example of it as possible, but it can actually go in depth with DNS. And it's not that bad to be a subject matter expert in DNS, okay? ARP, one of the most beautifulest things that were created, right? Address resolution protocol. Okay. ARP typically within the OSI model, right? TCP/IP stack, right? It's roughly layer 2.5, right? Why is that the case, right? Because it operates with both IP addresses and MAC addresses, right? So what does ARP do, right? ARP maps IP addresses to MAC addresses. This is how our hosts are able to say, hey, I have the IP address, right? But what's the MAC address for this IP address? Because I need to go ahead and send this traffic on the, to this host, but I can't send it unless I know the destination MAC address, right, to send it to. Okay. So ARP helps with that by doing an ARP request, right? AKA a broadcast message to the entire domain, right? And of course, the host to where the conditions match, right, via IP address, it is going to respond, right, with an ARP reply, all right? And that is going to be a unicast, right, a direct message back to the source, right? Okay, right? That's how ARP works, right? And of course, right, within each host, right, it's going to have a ARP table, okay? And this is how ARP table works, right? You have your IP address and it's going to map to that MAC address, okay? And of course, on that ARP table is going to have the interface to where you learned this IP address and this MAC address, okay? All right, last but not least, right, the ping command, right? Layer 3's reachability feature that is used, right? AKA ICMP request and reply, right? Pings are one of the most powerfulest tools to network security engineers. And of course, you probably use it on a FortiGate, right? Pings are used to test layer 3 reachability, right? Right. So this technology is created, right? It's right above, right above, layer 3, right? And it is used to confirm reachability, right? Hannah's trying to ping Harold, right? Harold's PC responds back with a ping reply, right? Or ICMP echo reply, right? We have ding, 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 reachability. Okay, as simple as that. Okay, one last thing that I need you guys to understand, and we're going to go over in depth on Saturday during Lab Fun Day, is route precedence, right? What does that mean, right? Well, every router, right, or every device that's, that's in charge of routing traffic, right? Maybe you got a layer 3 switch, right, or a multi-layer switch, I'm sorry, right, to go ahead and operate at layer 2 and layer 3, mostly layer 3, right? Right? We have our router tables, we have routing logic, right? But what is the precedence, right? How does, when packets come in that are received by a router, how does it know where to send it, right? It has, it has subnets or what have you, right? It has a routing table, right? But there is an order of operations, right? That it uses, right? Tiebreakers and all, before it says, hey, okay, use this route that's installed in this routing table to go ahead and send this traffic to, right? And it's called route precedence, okay? So when a router receives a packet, right, it's going to say, hey, I received the packet, I did the lookup, right? How do I choose the best route, right, in my routing table, right? First, it's going to go by the longest prefix or route specificity, right? What does that mean, right? So if we have two routes installed in the routing table, right? We have a 172.16.1.0, right? /16, right? So we have a /16 in the routing table, but we have a 172.16.1, right? .0/24, right? So whenever we say the prefix, we're talking about the CIDR notation, right, at the end of an installed route, right? And so when they refer to the longest prefix match, they're speaking to, if we're talking about the CIDR notation in bits, we're talking about the route that has the most bits that are turned on in its subnet mask, right? So there's more bits on in a /24 than a /16, right? That's telling the router this is more specific than a /16. So that router is going to use that route versus another, okay? That's the first thing a router checks when it's trying to see which route to use, right, and where to send it, right? Second, let's say there's two routes on the table, right? Two routes in the table for the same, same prefix match and everything, right? How do we choose what's next, right? The next deciding factor would be administrative distance, right? And from, connected routes, local routes, and static routes, and dynamic routing protocols, right? They all have an administrative distance, right? And what is that administrative distance, right? The administrative distance is a number, right, that represents a level of trust to that device on how much that device trusts the route that has been installed in the table, right? And of course, the best route would be one with the lowest administrative distance, right? The closer to 0, the more you are trusted, right? So a static route, being roughly having an AD of 1, is going to be more trusted than a route from OSPF that has an AD of 110. Okay, right? That's how that works, right? That's how AD works, right? The tiebreaker for the longest prefix match or route specificity, right? But let's say we have a tiebreaker for the admin distance, right? Two routes, they both match up at rule number 1 and rule number 2, right? Next, we need to go ahead and check the metric /cost, right? Every dynamic protocol is different. Every routing method, different static routes, they're different, right? You can assign a cost to static routes and all that, right? So it would use metric /cost to do the tiebreaker to see where it would go ahead and which route it would choose and where to send it. Okay? All right? And with that being said, that is routing in a nutshell. Any questions?
Yes, I do just have one question just about administrative distance and
Okay.
fail. So when you have a two wins and you're configuring a failover, the only difference would be the priority in that case? Or would it be the AP?
Let me ask you. So you're asking about route precedence as it relates to SD-WAN?
Yes.
So great question, right? But there's a little bit more factors that come into play,
Okay.
right? So how route precedence is chosen with SD-WAN, right? There's a couple of things that you configure, right? You configure your primary link, right? If you're going, depending on the methodology that you use, right? If you're doing your SD-WAN strategy by maybe, right, the link that has the lowest cost, right? It's going to look at that first, right? It shares the SD-WAN links, right? The two links, right? Three links or what have you, that is involved in SD-WAN. It shares the same routing table, right? It's a matter of which WAN link I'm going to use over the other, right? Because the goal of SD-WAN is to optimize wide area networking, okay? And so it's going to look at first, hey, is this device using a specific strategy, right? Is it using the link based on cost, based on reachability to this target, or is it manually set to use, maybe the link to Spectrum, right, versus the link to AT&T, okay? Once that is selected, then it's going to go through the route precedence that we just went over. That makes sense?
Yep, it does.
Okay, cool.
That was
Cool.
my only question though.
Okay. All right, man. Well, hopefully this was simple enough. Hopefully you guys understand routing and switching. And Saturday we will have a exam/quiz, right? A refresher that I will not be helping you guys with. We will do the path of a packet again. Okay.
Okay, sounds
Uh,
good.
all right, guys. You have a good night.
Bye.